And the first presentation is by Patrick Hanks from the University of Wolverhampton. And the title of his presentation is Words are ambiguous, but patterns are unambiguous.
Thank you, Carol. I need my notes from over there, so just a moment. It's okay. I know what I'm looking for, I think. Thank you. Okay. So one of the themes of this conference is lexical resources, presenting strategies for structured dynamic presentation of linked lexical data. I'm going to offer a new interpretation of the word linked. And I'm going to tell you that after 30 years as a lexicographer, I reached the uncomfortable conclusion that words don't have meanings. But I rescued myself by saying that they have meaning potential. Meaning potentials are activated in different ways of each word by context. Contexts can be found in patterns in a large corpus. So I've gone from being a lexicographer to being a corpus analyst. So I'm asking some really fundamental questions. What is meaning? How does language work? A theory-laden question. It looks innocent enough, but believe me, it's very theory-laden. How do people use words to make meaning? I'll leave you to figure out the theoretical implications of that approach. I've already said words don't have meanings. They are used in patterns. So the theory of norms and exploitations, which we're investigating in Wolverhampton, I'm investigating with my colleague Sarah Morget. Stand up, Sarah, and thank you. You now sit down again. Is a new approach to studying lexis and meaning, corpus pattern analysis. It's not that new, because I've been doing it for a long time. So the idea is to identify, not ask about what does this word mean, but ask what patterns does it occur in, and attach meanings to patterns, not to words. I'll do this very quickly because we're short of time. Many of you have heard, those of you who've heard me lecture before have heard this example before. What's the meaning of blow? Well, anything you answer, I'm going to contradict. If you say it's what the wind does, I'll say it's what I do to money, and so on. Same with blow up. Blowing up a building is different from blowing up a balloon. And if I blow up intransitively, I lose my temper, and so on. So words, I think, are hopelessly ambiguous. The astonishing early finding of corpus linguistics, those bits of corpus linguistics that are aimed at studying meaning, is that patterns are appear to be unambiguous. Now the challenge is what counts as a pattern. I'll go through this very quickly. 12% of uses of blow are to do with something like the wind blowing usually in a certain direction, but a gale was blowing is perfectly grammatical in English. No direction. There's an implicit direction. A gale has to blow in a particular direction. And looking ahead, it isn't only gale, it isn't only wind, it's also a breeze, a light air, a hurricane, a typhoon, and so on. I expect you've read the rest of this slide. If you haven't, you can have copies of the slides later. Idioms are, in our definition, patterns where the lexical sets are severely impoverished. If you blow your own trumpet, you can't talk about somebody blowing their own bugle, still less about blowing their own clarinet and activate the same meaning. But of course you can if you're exploiting the norm to blow your own trumpet, and in some context where clarinets are particularly relevant. So that's how language works. Blowing the whistle on someone or on the government. You don't need a whistle to be a whistleblower, and so on. So we've got the problem of idiomaticity, which also is solved by this kind of presentation of words in patterns. The bottom line of this presentation of blow, very brief glance at blow, is that it's impossible to learn all possible uses of a word. Word use is infinitely expandable. So we're doing something very different from what Corrie was talking about this morning, earlier this morning. We're not searching for new words and new meanings. We're searching for the way the central core works. And we're creating a patterned dictionary of English verbs, which I've been doing for about 10 years, and in Brno and in Wolverhampton, and we're still working together. Are there any Brno people here? Mostly Brno people at this conference. Anyway, we get tremendous support from the Masaryk University Faculty of Informatics. Thank you to you and your colleagues. The aim is to find the patterns with which each word is being associated. In this talk, I'm going to say that everything that I've said so far applies very neatly to verbs and to predicative adjectives. Quite recently, in the last couple of years, I've been starting to ask, what about nouns? The second half of this talk, if we get this far, Madam Chairman, will be about nouns. So, what is a pattern? Well, a pattern consists of a syntagmatic structure. For verbs, it is subject and the verb itself, the predicator, and one or two objects. This is very Hallidayan. And an adverbial, otherwise known in Halliday's grammar as an adjunct, which is not what generative grammarians call an adjunct. Linguistics is a terminological minefield, quagmire, any metaphor you like. It's probably a quagmire with mines in it. But the point is that, as John Sinclair said in 1998, many, if not most, meanings require the presence of more than one word for their normal realization. If we're going to study meaning, then what lexicographers do is wrong. Because we look at, as lexicographers, we look at words in isolation, and then we look at some contexts, but we don't try to systematically generalize over contexts. And collocations must be grouped into lexical sets. Why? Because taking an idiom that Rosamund Moon mentions in her book on fixed expressions, which are not fixed at all, as she correctly points out, there's an idiom about shaking in your shoes, but you can also be quivering in your boots or quaking in your wellies. There's an example in one corpus I looked at with policemen quivering in their size 14s. We know what size 14s are. They must be some sort of footwear. So we need the lexical set, we need semantic types as a means of grouping collocates by some common feature, by their most common feature. We also need semantic types because many lexical sets are huge. So a problem of the sketch engine is, or the version of the sketch engine, you've probably moved on since I last looked, but a problem is that the argument human is not spotted by the sketch engine because there are so many lexical realizations of the semantic type human that we don't see it. And the same with physical object and event. But if we find 3 or 4 examples of grasping the nettle, again, we've got an idiom where the word has to be nettle. You can't Americanize this by talking about grasping the poison ivy, or if you did, you'd be being creative. So we have an ontology of only 220 semantic types, unless it's grown since I last looked. Where's VTech? Well, it may or may not have grown. Anyway, around 220 semantic types. It's almost so small that a normal lexicographer can carry it in his or her mind while doing lexical analysis. And we can certainly memorize the most frequent ones. And it's hierarchical, so a human is a physical object, amongst other things. There's multiple inheritance, so it's also a human can be a cognitive object and so on, a legal entity. But both of them go up the hierarchy, just as in WordNet, except we're dealing with concepts, not... we're using concepts to classify lexical items, whereas WordNet uses words to classify other words. So there are 2 top types in our ontology. One is entities, and the other is eventualities. And eventualities are called eventualities because we want to include states of affairs, static events. So we call them anything that is both static and active is an eventuality. And these semantic types serve to disambiguate the verbs. These semantic types, when applied to nouns, serve to disambiguate the verbs with which they co-occur. Okay, it's changed colour. this is part of, it's changed colour, I think, as part of the war between Microsoft and Apple. I've been caught in the crossfire this week. I won't take the rest of the lecture telling you the sad story of my week, but it's a very sad story. Okay, so we look at the verb grasp. We look at the physical, we look at the direct object. You grasp horns, you grasp the edge of something. Oh, good God, I've only just started. You grasp a handle, you grasp a creature, you grasp somebody's hand, you grasp Maggie. They're all physical objects. You grasp the truth, you grasp the rules. They're all mental objects. Moving on, let's see what colour this is. Oh, this is interesting. At least it's systematic. I didn't intend it to be red. Of the abstract nouns are the devil to classify. They're extremely difficult, right, Sarah? Yeah. But we need to distinguish grasping an opportunity from grasping other kinds of mental objects or abstract nouns. Grasping a chance, an opportunity, and the moment turns out to be an honorary member of the set of opportunities. Then you have, in group 4, you have a set of, with the nettle, which I've already mentioned, grasping the nettle. Group 5 is the conative alternation, grasping at something, which means that you try to get it, but the speaker or writer does not commit himself or herself to the success of the grasping action. You grasp at the bedpost, you may never get there. And incidentally, generative linguists deny that this conative alternation exists, but then their evidence is their own beliefs. So, what can you say? Moving on. Oh God, right. No. I'm going to eat into question time. We're not going to have any questions. Yeah. Or I'll keep talking until I'm dragged out, kicking and screaming. We need a different. Okay, so that's roughly how we do verbs. Let's look on to nouns very quickly. The first thing to say is there's not a stable syntagmatic relation between the collocates in doing noun analysis. Hospitals and doctors co-occur in lots of sentences. They are clearly significant collocations in the corpora I've looked at, but there's no syntagmatic relationship, no normal thematic. Okay, and the other thing to say is that the verb collocates are stable, but the noun sets themselves are not necessarily stable. So you've got storms, hurricanes, and gales abating, and things that abate have the semantic type weather event, but they need the added property violent. You don't talk about a light breeze abating. Okay, so I took the word shower as an example, and I looked at all the collocates in the British National Corpus, not only those that I used the sketch engine for guidance, but I also looked at things that took my fancy in the corpus. And I found that there are all sorts, and you can make up a story like this, and this is tremendously important, I think, for learners, in order to learn how to talk about showers in English, should they ever wish to do so. You need to know, well, there are showers, and a shower is a weather event, and it's a short downpour of rain. But it's also, there are snow showers, wintry showers, hail and sleet showers, a heavy shower, a light shower. I won't go on. What do showers do? They sweep over or across locations. After a short time, a shower dies away or out. the shower is said to be clearing. What happens to people and showers? People get caught in a shower. This is all so boring that nobody but a lexicographer would bother to go through and classify it. It's important for understanding how the language works. Second group of senses, showers are provided by an architect. They are installed by a builder in a cabinet. Put it away, it makes me feel ill. Or in the bathroom, or above the bath, or in a separate shower room, and so on. You starting to get the idea. A shower is an event. This is the weather event. But no, sorry, it isn't. This is in contrast to the weather event. A person takes a shower, has a shower, and it may be hot, cool, or cold, and it's refreshing. And this is language not typically used of a downpour of rain. Okay, and I think, oh my goodness, this looked like the end. So we're doing systematically we're creating a pattern dictionary of English verbs. We've done, how many is it? About 1,700? We've done 1,800. We will, unlike FrameNet, we'll know when we've finished because we know that in the British, thanks to Sketch Engine, we know that in the British National Corpus there are 5,600 and some items tagged as verbs, lemmatized as verbs. When we've done all of those, we've got a pattern dictionary of English verbs. We can then move on to predicative adjectives and nouns. And there are parallel projects going on with Irena Renau, Araki in Valparaiso, but I've left the accent off, I'm in disgrace. And Elisabetta Ježek, who despite her lovely Czech surname is Italian with a Dutch mother, at the University of Pavia. Okay, so that's it, thank you.
Well, thank you, Patrick, for this delightful and perfectly timed lecture. Are there any questions? I think we have time for 2 or 3 questions.
Oh, good. No, they're all so gobsmacked. Oh.
Thanks, Patrick. I wonder what you think about the scope of your semantic types. Are your types, is it a fact of standard British English, or is it a fact of language, or is it a fact that could also be further subdivided into dialects?
Very good question. The first thing to say is that Elisabetta and I think Irena are using the semantic types with their English names for concepts that group together words in Spanish and Italian. So they are language universals. The next thing to say is that in the words of a paper that Elisabetta Ježek and I wrote, semantic types shimmer. So it's not the case that all semantic types, all members, all lexical items in a semantic type can be used everywhere that semantic type occurs. So the example Elisabetta and I give is you attend an event, such as a meeting, but there are some outliers, like attending a school. A school is not a meeting. It's not an event. But you go there for the event. It's a building, I think. But then you go there because of the events that take place there, and so on. So what we have to do, I'm sorry to have to say, is to study the lexical items of each argument of each verb independently, And we just use the semantic types as a grouping device. And we know that as we move from verb to verb, some words come in and others go out. But we think they're language universals or conceptual universals.
One last question.
Everybody's leaving. Oh, no, you're not leaving. You're going to ask a question.
Sorry, I was just thinking that maybe this need for pattern analysis is bigger in English than in other languages that have a more developed inflectional system, like if you take Arabic or Finnish or something like that.
I didn't hear, but I didn't understand the question. What's the question? The question is,
Whether
is it English specific? No, it isn't.
Yeah, I think that other languages with a more developed inflectional system has
Inflectional
more of
system.
this information
No.
in the words.
Okay, English and Chinese are word order languages, and the first step in corpus pattern analysis is to identify subject, verb, object, and adverbial. In inflected languages, you do it by looking at the endings. So they are inflectionally organized languages. They still tell you what the subject and what the object is. You still know if the bus hits the car. I don't know, busso, what's the bus hits the car in Czech? It'll have some inflections that tell you which is the subject, who's the guilty party, who did what to whom. And that, I think, is going to be universal for all languages but needs studying. Except German, of course, which has a bizarre mixture of both word order and inflection. But then German is interesting.
Well, thank you once more, Patrick.
Good. Oh, I should take this off. I'll take, well, you, okay. Thank you. Oh.
The next speaker in this session is James McCracken from Oxford University Press, and he's going to talk about semi-automatic expansion of the Historical Thesaurus of the OED.
Thank you. So I'll just start by saying a little bit about what the Historical Thesaurus is. The Historical Thesaurus is a very deep, granular taxonomy of all the content in the OED. It was compiled as a project at the University of Glasgow between 1965 and 2010, published in book form in 2010, and at the same time it was integrated with OED as a data set, so it now forms part of OED Online. This is how it appears in the book, which sort of to some extent disguises the sort of taxonomic nature of the thesaurus. But in OED Online, that the kind of taxonomic structure becomes much more apparent. So here you see so this is the part dealing with parts of the head, parts of the face particularly, and then down to the nose. So the taxonomy on the left-hand side, and then the particular lexical items in the OED that have the specific meaning of nose. And you can see here that these are shown in chronological order. So this is just the kind of first part of a very long list of words in English for nose over time. So this provides and these all link to the senses, the particular senses in the OED, so you can jump back and forth between the thesaurus and the dictionary and effectively browse the lexical content of English semantically and by concept over time. So it gives a quite new and different way to explore the content of English historically, and allows you to do very interesting things with the OED data set that weren't possible before. The problem that this project deals with is the fact that not all of the content in the OED is currently classified in the Historical Thesaurus. So in fact, if we look through every sense in the OED, every sense of every entry, there's about 821,000 in the OED at the moment. 2/3 of those do have at least one classification. They do link to at least kind of one point in the thesaurus. But about 1/3 currently don't. About 264,000 still remain to be classified. There are various reasons for that. Some things were systematically omitted from the original thesaurus project. But more interestingly, as the OED continues to be revised and updated, new entries and senses are added, things get split, things get broken up, and so on. And there are also a few things that were just missed sort of by accident and haven't really been mapped correctly to the OED and so on. So there's about 264,000 things that still remain to be classified. So what this project is an attempt to sort of complete the Historical Thesaurus by classifying these missing senses. And we're trying to do this semi-automatically, so with a machine learning process that can use the existing classifiers as training data for a machine learning process to classify the rest. And then using human input to evaluate and accept or adjust those classifications. So on the face of it, this is a really attractive machine learning exercise. There's 557,000 items that have been humanly classified by an academic project, a sort of very well-trained, highly motivated team of people at University of Glasgow working through the dictionary. And on the face of it, this would be a really nice set of training data to use for machine learning. There are some problems, however. One is that the thesaurus taxonomy is very granular, so the amount of training data that you have drops very steeply as you go down the tree. And it's also a sort of quite a bottom-up taxonomy. So it was really developed largely by looking at what was in the OED at the time the original project was working. So a consequence of that is the taxonomy is shaped quite specifically by the content that was being dealt with at the time. It doesn't always leave kind of room for new senses to go in, or it doesn't make it obvious where they should go in. The input senses, so the stuff we're trying to classify, isn't altogether similar to the training data for various reasons. And the individual documents, so the individual senses, can be very short and feature poor. And I'll show you some examples of that. And the other thing to bear in mind is that the OED has an unrestricted defining vocabulary. So from a machine learning point of view, there may be patterns that you come across in the senses that just aren't there in the training data. So these are sort of some examples of the type of thing we're dealing with. First two really quite relatively rich senses, quite long definitions. You also have the quotation information, which also serves a function in machine learning point of view. There's data that can be drawn out of that. But then the last example, keratost, is perhaps more typical. You've got a kind of very short and in some senses quite misleading definition there. And just one example from the Lancet, which tells you it's probably something medical, but other than that, it's sort of quite limited information that you've got there. So for these reasons, I developed a sort of hybrid strategy, which uses sort of two main routes to analyze. Firstly, the input sense is analyzed with what I call a topic classifier, which is essentially a naive Bayes classifier, which is adequate in most cases for classifying senses to sort of a relatively high level in the taxonomy. So essentially figuring out which branch a given sense belongs to. And then there's a sort of battery of more targeted classifiers which work within that branch to try and figure out where this sense belongs to specifically. And then there's a central classifier which brings that information together, looks for commonalities among the results from the targeted classifiers, looks at what matches the topic classifier, and tries to come up with a sort of best guess classification for for the input. In some cases, 2 or 3 classifications. So the targeted classifiers, as I say, are working with a sort of pruned version of the taxonomy. From the topic classifier figures out which branch is most likely, and then these are particular strategies that work within that to try and figure out the particular node within that branch that the sense belongs to. So there's a battery of these strategies which I'll talk through briefly, and then the central classifier looks for a sort of consensus among those, or failing that, kind of looks at one which is giving the best confidence in a given context. So here's some examples of the particular methods. Cross-references are very useful. So in this example of net tracery, there are 2 cross-references in that definition which are pointing to particular senses of tracery and reticulated. And so by looking at how those are classified, we can kind of triangulate on where this sense should be classified. A lot of the input senses are plant and animal names, that kind of thing. And if we have a binomial or genus term in the definition, we do in case of palmetto bug, there's a model that looks at where other terms with those binomials cluster in the thesaurus and uses that to classify. Synonyms, the OED doesn't really give sort of explicit synonyms in the way that some dictionaries do, but there are certain patterns within a sort of typical OED definition that are quite synonym-like. So party foul here is sort of one of those typical patterns where you have a sort of paraphrase gloss followed by a semicolon and then comma-separated, effectively synonyms. So in here, if you kind of know that pattern, the system can pick up faux pas and mistake as kind of near synonyms of this term and look at how they are then classified and use that again to triangulate. Party foul should be classified. There are certain problems with that because they're often not quite synonyms in that sense. But I talk about that in the paper, how to interpret it. Morphology, so often things that are derived terms, like say metalsomeness, we can look at how its parent term, so if metalsome is classified in the thesaurus, then that will again give us indication that metalsomeness should be classified. And on a similar theme, compound forms, which make up a large part of the input. There's a separate model that's built by analysing where the first term in a compound clusters in the thesaurus, where the second term clusters, and again looking for ways to triangulate on that. And the final example I'll talk about here of sort of targeted classification process, trying to identify the superordinate within OED definition can be quite awkward for various reasons, that they're not, OED definitions quite kind of various in how they're structured, but again there are certain patterns to identify the superordinate within a definition. So here, blanket or sheet can be picked out as the superordinate, because from the topic classifier we've already determined that this is a printing term. We can again look for, are there areas in the thesaurus, in the printing branch of the thesaurus, where other senses with blanket or sheet as superordinate cluster. That will then. So there's a bunch of different methods that are used here to try and get down to a particular node within the thesaurus. Not all of which work for every sense, but kind of as in some, usually at least 1 or 2 of them will provide some information for a given input. And that can allow the system to good guess as to where a particular sense. So here's some evaluation on this. First of all, I should say that of all the input senses, about 86% are being given a classification of some kind. So there's about 14% which the classifier is just not getting But of those that are being classified, 25% being classified down to the correct node. And about 22% are being classified sort of somewhere in the right region. So often it's kind of sibling node or parent node or a child that's sort of one step away from B. Further 18% being classified on the correct branch, so it's kind of getting into the right territory, but often that's sort of 2 or 3 steps away from where it should be and perhaps more distant to be directly useful. 33% are, at this point, are sort of completely incorrect, so on a wrong branch altogether or just too vague. And then there's a small number where the evaluation process just wasn't determined where. I'm sorry, is this not picking up? All right, I'm sorry. Is this any better? Okay, I need to speak down. This is with about the thesaurus has about there's about 200,000 possible points in which any given sense could be classified. So on that basis, I think this is sort of quite encouraging. It's obviously getting it wrong enough of the time not to be kind of let loose on its own. So what I've done is build an interface where we have a team of people working through the results of the classifier and marking those that are right, those that are incorrect, and there's also an interface here for kind of being able to adjust something to a neighboring node or kind of moving it around. So in some cases, even if the classifier has got to precisely the right node, it's a relatively simple step to kind of shift it to a neighboring node and get it to the right point. So we're kind of increasing the amount of information here. These results can then be iterated on. We can kind of move them back, roll them back into the training data and iterate the process and sort of gradually improve and increase the thesaurus on that basis. Sort of work that remains to be done. We really need to extend the taxonomy. One of the things that has become clear in this process is that a lot of the new material in the OED just doesn't fit anywhere in the thesaurus. It's either often kind of new concepts, new areas of the language that just weren't accounted for in the thesaurus. Or as I said before, because the thesaurus is quite kind of bottom up, determined by the shape of the OED as it was, it just doesn't leave room for new senses. So we need to do more work on extending the taxonomy. Often OED senses are have kind of several clauses in them that and really indicate that this definition belongs in sort of several points in the thesaurus. And at the moment, the classifier is really attempting to provide a kind of single best guess in each case. And we need to do more work in identifying where a definition is really saying 2 or 3 different things that need to go into different points. One of the difficult things is that the OED doesn't really give very good, OED defining style doesn't give very good separation between sort of paraphrase part of the definition and meta-language. They're often quite mixed up. And that can lead to errors when the classifier picks up a bit of meta-language. So that's something that we need to improve. One of the things that this relies on is being able to identify the core senses of a word. So for example, when I was talking about using synonyms, having identified a series of synonyms for a given input sense, you then need to look at how those synonyms are classified. But if you can't identify the right sense of those synonyms, you've got a problem. And of course, the OED orders senses not by frequency, but by chronological order. So it's often a difficult problem to work through a core entry and find the most likely sense that was being used elsewhere in a definition. And that's kind of an interesting problem in its own right. The other thing that I found quite interesting about this is that the machine learning process tends to classify on the basis of what something is. So it will often kind of pick up formal parts of the definition, explaining what something is, what it's made of, what it looks like, rather than the kind of utilitarian part of the definition, what it's actually used for in human terms, what its function is. And from a lexicographic point of view, that's often the more salient feature. So you often end up getting things classified, so a basket for carrying bricks in ends up being classified with a bunch of other baskets rather than in the kind of brick-making apparatus part of the definition, part of the thesaurus, which might be the more salient place to classify it. So that's sort of been a really interesting part of this. How do you separate out those two aspects of a definition and figure out where something should go? But then, as I said, the large part of this further work is just feeding the results back in and iterating, getting gradually. So if you want to look at more of this, the classifier itself, the interface that I showed a little earlier on, this is at htclassifier.com, password for this conference. So do feel free to go and have a look at that. And if you want to explore the thesaurus itself, and I very much encourage you to do so if you haven't, really fascinating. That's in the main od.com site, od.com thesaurus. But even if you're just browsing the od.com through the main entries, each of those have sense. You will have a link, typically have a link to thesaurus. It is well worth exploring. It gives a sort of fascinating, different view of the lexicon than was before. So I'll stop there.
Are there any questions?
Did you find that one part of speech or another was easier or more difficult to classify?
Yeah, it does vary a lot with part of speech. I mean, most of the content is nouns. I mean, more so than the dictionary as a whole, because nouns tend to be overrepresented in the new content being added. And also, a lot of the compounds will be nouns, and compounds are overrepresented. So I spend a lot of time working on nouns, but actually those are quite difficult. Adjectives tend to be the ones that are most susceptible to the kind of synonym-like approach. So that's often very helpful. I did do some evaluation of different parts of speech. I think adverbs are usually pretty straightforward because you just have to look up the classifier of the parent adjective or whatever. So and usually that's sufficient. So I think adverbs, it's unfortunate that the easiest ones to do are the smallest sets. But adverbs I think give the best results. Adjectives I think were the second best. And then nouns and verbs, we think about equal, and both have their own problems, but they're different.
Did you perform any experiments on the time savings obtained when using the tool?
On the time savings?
Yeah.
Yes, so we had some, we originally had a project where a number of people were just going through trying to classify sort of from scratch. I don't have the numbers here, but yes, it's much easier. It's certainly a kind of a lot quicker. Even if the classifier is wrong, it's often it's often close, and actually it's often that being able to get someone to the right branch quickly, and then it should be kind of fairly obvious where the right node is. The other problem with people with sort of trying to classify from scratch is that often people end up classifying at a kind of suboptimal place in the thesaurus. So they find somewhere that looks kind of good enough, but actually don't notice that there's somewhere else in the taxonomy that would have been better. And the machine learning tool is quite good at identifying sort of optimal branch, even if not the optimal. So it's not just a kind of time saving, improving accuracy. Yeah.
I thought there might be somebody else before me. Yeah, James, I question out of deep ignorance, but does the thesaurus allow for multiple inheritance? And if so, how would you cope with it in? Yeah, how would you in your work?
It doesn't currently allow for multiple inheritance. But I've been talking to Mark Alexander, who now runs the project at the University of Glasgow, and we're talking about ways to handle that. So I think that is becoming more necessary. So I think that's when I talked about extending the taxonomy. Partly it's just kind of adding more branches and nodes in taxonomy. Partly it's also thinking about those kind of questions. Yes.
Your basket example was
exactly. Yes.
relevant.
Yes.
I may have missed something, so I apologize in advance. But could you tell us just a little bit about the technical side? What is machine learning for you? What programming language do you use? What's actually happening there? And for your browser, is it just a regular relational database? Do you use XML in the backend? Like, what's the technical backend?
Well, okay. So this is the kind of build is separate from the interface. So the interface is just written in Django with a Postgres backend. So yes, that's just relational. The classifier itself, the topic classifier is fairly straightforward, naive Bayes classifier working on, and in the paper I talk about the kind of feature set that uses. Yeah. Yes. And it also talks in more detail about how the particular kind of targeted classifiers work. So.
Are there more questions? Yes.
So you said that you will have to extend the taxonomy, which from a machine learning perspective is certainly the worst thing that you can do. And you didn't report, so my question then is, you didn't report numbers on a higher level decisions of the very first levels. So you said that so and so many nodes are classified correctly.
Yep.
And given your taxonomy has a sort of a hierarchical structure, have you got numbers of how well did it actually classify if you only take the first two levels or something like that?
Oh, I do have those figures, yes.
It sort of relates to the question, how much time saving does it give you to use such a technology? And then if you say that, well, my classifier does very well for the first two levels, then I'll sort of just pre-select these nodes and then have the humans do the rest of the work or something.
Yeah, that's possible, and in fact there are so the correct branch numbers are those which have kind of got down to, I think, levels in the taxonomy where there are 2,000 or fewer instances kind of below that point. So effectively, if you add that kind of 18, 22, and 25, those are the ones that are effectively kind of on the correct branch it's typically down to the first 2 or 3 levels of taxonomy. I mean, the taxonomy is quite uneven in that.
Yeah, I figured some of the sentences hinted at that it's not.
Sorry.
That some of the somewhere in between what you said hinted at that it seems that your taxonomy does not always go to level 7. So it seems that
Yeah.
some parts go to level 4 and some go to level, I don't know what. Yeah.
Thank you very much. I think we need to stop here. So I would like to thank James for his very interesting paper.
Thank you.